Assalamualaikum, welcome to our YouTube channel. Frequency reuse because of limited bandwidth allocated in the 800 MHz band for cellular radio communication. Frequency reuse is crucial for its successful operation. A certain level of interference has to be tolerated. A major source of interference is co-channel interference from a nearby cell using the same frequency group as the cell of interest. For the 30 kHz bandwidth, AMPS system reference 15 suggests that C be at least one database. The primary oscillation derives from the distance between the two cells with the same frequency group. Refer to figure 10.19 for the definition of the parameter R and D. D is the distance between cell center of repeating frequency groups and R is the radius of a cell. We let a dash A is equal to D over R. The D over R ratio is the basic frequency reuse planar parameter. If we keep the DR ratio large enough, co-channel interference can keep to an acceptable level. Lee calls it the coal channel reduction factor and relates path loss from the interface source to R4. A typical cell in question has 6 co-channel interference on one on each side of the hexagon. So there are 6 channel interference sources. The goal is C over 1G 18 dB or a numeric of 63.1 point. So this means that D must be 4.4 times the value of R. If R is 6 mile, then D is equal to 4.4 multiply 6 is equal to 26.4 miles. Lee reports that the co-channel interference can be reduced by other means such as directional antennas, total beam antennas, lower antenna height, and appropriately selected site. If we consider a bias 26.5 mile path, what is the heat of Earth curvature at mid-path? From chapter 2, H is equal to 0.667. The total available bandwidth is split up into n sets of channel groups. The channels are the allocated channels. The channels are then allocated to cells. One channel set per cell on a regular pattern which repeats to fill the number of cells required. As n increases, the distance between channel sets D increases, reducing the level of interference. As the number of channel sets n increases, the number of channels per cell decreases, reducing the number of channel sets is a composite between capacity and equality. Note that only certain values of n lead to regular repeat patterns without gaps. Cell splitting can take place in urban areas in some point in the time because the present cell structure cannot support the busy hour traffic load. Cell splitting in effect provides more frequency slots for a given area. Mercurio supports that cell splitting co-channel interference tends to increase with splitting. Cell sectorization can cut down the interference level. Figure 10.16 shows a 3 and 6 sector plan. The 3 sector plan is often used with a 7 cell repeating pattern resulting in an overall requirement for 21 channel sets. This result is an overall 24/7 set requirement. Sectorization required a large number of channel sets and fewer channels per sector. Outwardly, it appears that there is less capacity with this approach. However, the ability is smaller used.